Hello everybody, in this video we're going to talk about different types of sampling and interpreting the slope and the y-intercept of story problems. Okay, let's first talk about the difference between a random and a non-random sample. In a random sample, you want every possible participant or every piece of data to have an equal chance of being drawn. Okay, if that isn't the case, it would be considered non-random. So let's look at number one here. You survey customers at a mall. You want to know which stores they shop at the most. You walk around a computer shop and choose 20 customers there for your survey. Okay, now this would be considered non-random. The reason it's non-random is because you want to know you're surveying customers at a mall, but you're only at a computer shop. That isn't a very good sampling. You're only going to get mostly shoppers who are interested in computers or computer parts, and so it's not a true random customer sample. Alright, so that's why this one is non-random. Alright, let's look at number two here. You want to know what freshmen think of their science class. You poll 100 freshmen by using a random number generator to pick students by their student number. Okay, so here it tells right away we are random. We got 100 freshmen, a pretty large sample, good enough to do, and it's assumed almost all freshmen take a science class, given it's a basic class. This would be considered a true random sampling. Okay, now we're going to talk about classifying surveys, whether they're biased or non-biased. Biased shows that the line of questioning is sometimes leaning to get the person who's being surveyed to answer one way or the other. Okay, so there's a question on a survey. Do you watch TV on Saturday like everybody else? The fact that they say the phrase like everybody else is pushing the person answering this question, oh, everybody else watches TV on Saturday, so I must too. Because of that little phrase, that makes it a biased sample. Probably what would make it non-biased is if it just said, do you watch TV on Saturday? And if they just ignored that little phrase, that would make it non-biased. Alright, let's look at number four here, kind of a multiple choice situation here. You want to estimate the number of students in a high school who ride the bus. Which sample is best? So we got the football team. Well, the football team probably isn't the best because, yes, they're going to ride the bus because they could ride to the football games. 50 students in the band, it limits it only to the students in the band. 50 students, it's not, notice the original question, you want to estimate the number of students at a high school. You're not saying which group, you're not saying if a particular sports team, you want a good sample of the entire high school. 7 random in the hallway, it's not a very big, the fact that this doesn't work, you're only doing 7. D is probably the best sample. You're going to get 100 students, fairly big sample size, lunch period, everybody has lunch, anybody at the lunch has a good chance of being selected. Alright, so that's probably of the 4 choices here, the 100 students during lunch is probably best. Alright, now we're going to turn our attention to the story problems and interpreting the idea of slope and y-intercepts and what that means in the context of a problem. So the function below shows the cost to attend the fair if you ride R rides. F of R equals 5 plus 1.75 R. What is the y-intercept? What does it mean in the context of the problem? What is the slope? What does it mean in the context of the problem? Well, let me write this function again. And I'm going to write it in this manner so that the variable term is first. See, and the reason I'm doing that so it matches this, y equals mx plus b. And you can kind of see what matches what. So the m, the slope, is the 1.75. And whenever you have number next to x for the slope in story problems, that usually involves some type of rate. Okay, so the 1.75 times r, that must imply, oh, it's $1.75 to ride one ride. Okay, $1.75 to ride one ride. Now, if you ride 2 rides, 3 rides, 4 rides, it doesn't matter. You would plug it in for that number in for here for R. Okay, so in the context of the problem, the 1.75 is the amount of money it costs to ride R rides. It's the amount per ride. The B, that's the y-intercept. In story problems, it is usually the initial or base amount. Alright, so it's like the starting amount no matter what. Look, so like, let's say you ride 0 rides. Let's say you put a 0 in for R. 0 times 1.75 is 0, leaving you with 5. Okay, so 5 must be the entry fee. Okay, it's like before you do any rides, but when you just enter the fare. Okay, it's think of this as the entry fee. $5. So no matter how many rides you ride, you still have to pay the $5. Okay, so that's kind of what we mean in to look at slope-intercept form of a line y equals mx plus b. Your m is your rate in the story problem, and your b is the initial or base amount, the starting amount. In this problem, $1.75 to ride a ride, each ride, but you have to pay the $5 to enter the fare. Alright, I hope that helped us clear up the different types of sampling and interpreting slope in the y-intercept. Thank you for watching.